Now let's look at copper cabling. Now this is probably most of, other than your wireless router at home and maybe your cell phone, most of the computers on campus are wired, and they're all wired with a copper cable with Ethernet. Now, there are certain characteristics of copper cabling, and they're just not one type. You've got different types of copper cabling. Now, why do we use copper? Well, it's inexpensive, it's easy to install. It definitely has a very low resistance to electrical current, but it does have limitations. It loses signal if you go too far, and it is very susceptible to signal interference. Now, data is transmitted along copper cables via electrical pulses. And then you've got a transmitter and you've got a detector on the other end that detects if a signal has been sent or received. Of course, the farther the signal travels, the more it deteriorates and maybe wouldn't be able to detect a signal. That deterioration is called signal attenuation. So the farther it goes, the signal attenuates, and if it gets below a received threshold, it may be not determined that a signal was sent. Now, timing and voltage values of electrical pulses are susceptible to interference. And the two types of interferences that come into play are electromagnetic interference, or EMI, or it could be radio frequency interference if it's wireless. Or second is crosstalk. And crosstalk is where you get wires that are too close together and they can actually interfere with each other. Have you ever hear somebody else's conversations over a telephone? Or if you're listening to a radio station and it starts getting to the end of its coverage, you may start hearing other conversations, other things come through. That's kind of like the wireless on the radio station is more of a wireless, but it gives you that same thing. It starts, neighboring signals start to interfere with each other. It's kind of a weird picture, but when you're first transmitting a signal, it comes out nice and crystal clear. But as you start going fewer and fewer, farther and farther line or base interference, it can get messed up. And what your system tries to do is the receiving computer tries to read that signal, tries to interpret it, and to see if it can come up with the same one. That's why if you remember your frame layout, there was a CRC attached to the end of that frame, because it was trying to say, did I get a good frame? Was I able to put this back together the same way it was sent? It came out this way, and if you notice here, it made a mistake. And it would compare those two, that CRC, they run a mathematical equation against the data here, and run that same calculation on what they perceive the data, and guess what? I run the same mathematical formula against data. I should, if I can get the exact same signal, those numbers should be identical, and if they do, they match, I've got a good signal. But when it encounters interference, sometimes this is taking place. Now, the question is, how do I get rid of interference? Well, I get rid of interference by wrapping the cable with a metallic shielding, aluminum foil. Now, granted, when I wrap the shielding around the cable, it makes it stiffer. So you got to be careful as far as what you're going to use. So when you're choosing your physical media, you got to look at, okay, am I going to be in a high interference section? If I'm not, then I can stay with unshielded Ethernet cable. Or if I'm in a factory and stuff, I can have a shielded Ethernet cable. Now, some companies requires you to put the cable in conduit, a metal tube, so to speak, to be able to run the cable through, which then would isolate the interference issue. Let's see. So you got to make sure you select the right cable. Is it shielded or unshielded? Make sure you understand what your interference sources are, and then make sure you're doing proper wiring stuff. Now, here's examples of different cables. Now, normal Ethernet cable that you run at home and stuff that isn't in high interference, it is called an unshielded twisted pair. As you can see, let's see if I can, that goes too big. But there is no aluminum around any of the cables. A shielded twisted pair, which is now I'm protecting against isolation. This is one I will run in a high interference area, and it's got this aluminum foil material around it to isolate, to protect these cable. Now, if you look at a coax cable, different frame out. Now, I don't have any twisted pair in it, but I do have the shielding. I got a core, and here's your metal conduit that's used. Now, you've probably played with coax cable, very stiff. It wouldn't be easy to run between walls and stuff. At least in my house, when they installed cable, they ran it outside the house and then went in and generated, a hole in the wall and to get it into the house, only because it's too difficult to move. If the builder had maybe access before all the walls got put up, he probably could have done it easier running it inside. But so you're going to use shielded twisted pair in an interference mode environment, unshielded twisted pair, which is probably most of the stuff you're going to run across, easy to use, easy to bend and go through. Now your unshielded twisted pair. Basically, why is it called an unshielded? One, it's not shielded. Okay, that's first thing. Second, so that means there's no outer jacket. There's an outer jacket that protects the copper wires inside, but no aluminum around it, or inside it or around the cables. Now, the twisted pair also protects each wire from interference. And I don't know if you've looked at some of these kind of, you can kind of tell they're, one's a solid, one's kind of a mix of blue and white and green and white and solid green. There are 8 different color patterns, and one of the standards tells you if I'm connecting 2 Ethernet cables, what patterns do I have to match? If it's a straight through cable, which means my connections are identical on both sides, then I can have the same wire pattern because I'm going to try to electrically send information down each of these electrical wires. And if it's what they call a crossover cable, or so there's different types. So just keep that in mind. That color-coded plastic insulation helps wires because each of these wires are protected in rubber. So I've got a little bit of insulation here. The twisting takes out some of the interference. The outer coating helps protect these wires. The shielded twisted pair, I've got the same twisting inside, the same color patterns, but each one of the pairs is covered, and then I'm putting a shield around it. I'm putting a braided or foil shield, depends on the manufacturer, and then I've got the outer jacket to protect the cable itself. Now coax, again, like I said, it's stiffer. Copper is used as the conduct, and it is a thicker copper. If you compare that to the dimension of the copper cable on the other, it is a lot different. So you've got your outer jacket, then you've got your, let's see if I can get back down here, your braided copper shielding, which gives you one layer. Then it's got a plastic insulation to kind of isolate the copper conduit, and then it's got the copper itself. Now you got different types of connectors that can go on this cable. There's a BNC, an N-type, and an F-type. All of it depends on what you're connecting to. Some of them are smaller, some of those are bigger, some of them are easier to work with. It just depends. I think most of us probably have in our house probably one of either the, I guess now I think about it, I've probably got all 3 of these on various devices in my house. So just know that there are 3 different types to connect coax: BNC, N-type, and F-type. Each has pros and cons, but you got to make sure the connector on the cable matches the connector on your device. So let me see. That is the end of copper cabling. I will return for UTP cabling. Talk to you later. Bye-bye.